morning children. I'm Nesril. I'm gonna teach you chemistry today. Okay. So I hope all are safe and well at home, right? So we are gonna start our online classes, right? So I think you have already started your first chapter. Actually, you have completed your first chapter in chemistry, no? Now let's go to another chapter. And before telling you which chapter, I'll just give you an introduction which relates to your chapter, and let's see if you can guess. Let me give you an example now. You go to your schools, right? As soon as you go in the morning, like what will you do first? You'll assemble in your assembly hall. What can you see there? You can see that everywhere from the starting that each classes are organized and made to stand, right? How like first nursery kids, then LKG, then UKG, then first, and so on till 10th, right? And why do you think it's like that? Why should they organize you to stand in such a manner? It's basically because for teachers easiness, like they are it's more easier for them to identify you, right? So, and also for the children, you also, what happens if you come as a highermost class, right? You come in the front and you just stand, and all your juniors or small kids stand behind you, and just they leave you to stand like that. They can't even see what's happening in front, right? Yeah, so what will they do? They have organized you into particular lines, like first row, that's again I'm telling you nursery, LKG, UKG, and it goes like that. So what is that organization called? They have classified you, right? They have classified you according to your, based on your classes there. So even your characters, right? You are a bit mature people that they are like running here, and they're small kids, no? So based on character, based on your size, based on your classes, based on your age, right? Yeah, so they are all classifications. So our chapter is also similar to that. I know you can see the board and you can almost read the heading, but still this is an example. So what is that chapter name? A chapter name is very related to what I told you, right? What is it? Periodic classification of elements, right? In that chapter name, we have two important words. What is it? One is a classification. What is classification? I just told, right? That is nothing but categorizing or classifying, that is separating each or grouping each and every substances based on particular, it is on different basis. Okay, maybe for example they group dry fruits separately, right? They pack it, whereas your wet fruits, in the sense your normal fruits which are not dried, the raw fruits, are sold like that. So it's not packed in a packet, maybe few are, but still. So there are different groupings, right? Similarly, in your fridge there are particular items which has to be kept in the fridge, that is your refrigerator, and others which have to be kept outside. You can't go keep your ice cream outside in the sun or in on top of your fridge, right? No, you should place it inside because it melts. So these all are particular, they are all classified according to its particular properties or characters, right? Even when it comes to you, how do you classify your friends? You may have a particular groups there. One of the group is based on you have similar characters or similar sports ideas or sports interest you have, so you will have that particular cluster, like a group. And next, another set of people are like they'll be very emotionally attached, or they are very good at music or dance, so they are all one group. So the classification is basically segregation or a grouping of a particular item or a particular substance based on its characters or properties or anything, quantity, quality, it depends. Okay, so that is classification. Now next word, as I told you, it's elements. What is elements? Elements can be defined as the purest form of any substance with similar atoms grouping together. Similar or same atoms actually. Same type of atoms grouping together. So example for an element. Let's take the easiest example that we are always, which is surrounded us and we are taking in a day, every second of our life. What is it? It's a oxygen, right? The oxygen. So what is it? It's an element, oxygen. uh, what is the formula for it? It's O2, right? So oxygen is the element and the molecule is O2. Yeah, so that's it. That is the element. You got the definition, right? So it's a purest form of a substance with the same kind of atoms grouping together form it. Okay, yeah. Now let's get in detail to our chapter. So let's see what it is. First, how many elements are there till now? How many elements are discovered till date? Anyone know? It's 118 elements. Okay, out of them 94 are naturally occurring elements. So what does naturally occurring elements mean? They are all already existing in nature or earth. Okay, but others are synthesized or derived from other ores. Okay, how many elements? There are 118 elements known till date. But all these elements discovered at the same time? No, all were slow, with a slow evolution. Okay, as the time passed on, different scientists came up with different experiments and analyzings to and find it all these 118 elements. Okay, so let's go in depth about let's study about the history of the discovery of these elements. How did they ended up in discovering such elements and how were these classifications? Okay, so let's see how the history of classifications started. So the first person who started, who was a stepping stone, let's say, because he was the first person to put forth this idea of classifying elements. He was none other than Dobberiness. Okay, what's the name? Dobberiness. So he stated a law. What did he? Its laws is a Dobberiness law. Okay, let it be. There's one more word which has to be added. I'll tell you. So what did he do? Yeah, at that particular time, when he started his discovery or classification, he actually took the natural occurred elements which were available at that time. What did he do? He took all these elements, he analyzed them. The only thing what he could actually he could get from analyzing them were small properties. Okay, there were at that time there was no option to they didn't have good instruments probably, right? So it was not so modern. There were no modern technologies and all like now. So it takes a lot of years to analyze even a single small property. So what did he do? He took all these elements which he could find and he started analyzing it. Took a lot of years and then finally he could find some similar properties based on the atomic masses of them. So what was it? He analyzed some particular similarity between its properties among few elements which showed the similar properties based on its atomic masses. What did he do? When he classified all them, he analyzed, he kept a set of groups, a set of elements which had a similar property one side, like that. And then finally what did he get? The result was he got that three elements. Okay, three elements in a group. So each group had three elements and those elements showed similar properties. So three elements in a group which showed a similar properties. Such three groups he could find. What were those? Let's see what were those. just open the page number 23, 24 in your textbook, and on the left side you can see a small table called Dobberiness table, that is table 5.2. Okay, so open that. Let's see what it is. I'll draw it on the board again. Let's see. Now, as you can see that table on the left side, you see few elements, right? That is 9 elements are put it in a group like in box, right? I've written those here with this set, okay? This 3 elements with its atomic masses here. So let's see on what basis, how did he put them in particular order like this, okay? So first he took lithium, sodium, potassium, okay? These are lithium, sodium, potassium. This is calcium. Sr means strontium. Ba stands for barium, chlorine, bromine, iodine. These are halogens, okay? Yeah. So now what did he do? He took atomic masses of lithium, sodium, potassium. He arranged it in the increasing order, right? Increasing order, as you can see. Then what is the speciality for this particular group is downwards, okay? Let's see what it is, and I'll tell you what did he conclude. So you can see it's 6.9. So let me just add it. 6.9 plus 39, that is the atomic mass of potassium, okay, divided by 2. We'll keep it aside. So 6.9 plus 2 gives you how much? 45.9 by 2, which is approximately 23. It becomes 22.9, that is approximately 23. So what do you see here? You see that this is 23, which is equals to this atomic mass of sodium, right? So what is the conclusion? It's like, the arrangement is like the first element, the atomic mass of the first element plus the atomic mass of the third element, and when we take its average, we are getting the atomic mass of the middle element. Did you get it? So what it says, it's simple, okay? So the Dobberiness Law of Triads states that in a triad, the atomic mass of the middle element is equals to the average mass of the other 2 elements, okay? So that is what you could see here, right? 6.9 plus 39 by 2, you can see that it was approximately 23, which was the atomic mass of the sodium. So similarly, the trend goes even here. So this is law of triads stated by Dobberiness, okay? Now that was the first step. I told you, right? He was like a stepping stone for other discoverers, like other scientists, for going further. So his law was actually not taken further, okay? It had a demerit, or it got a failure. Why is it? Let's see what it is and why it happened, okay? What was his failures? Let's see in detail. So as time passed on, other scientists or chemists started analyzing using his formula. He started investigating on what it is actually. Then they found out that this wasn't true for all elements. This wasn't applicable for other elements, okay? So as time passed on, I said even the number of elements were kept on increasing day by day. Not day by day, though it took years, but yeah. Those elements couldn't be put in the same classification group, you know. This table couldn't be proceeded like this because they had no similar properties based on triads, okay? So his theory became a utter failure there. But then, did scientists stop there? No, they did not. So others took as this his step as an motivation or initiation, and what did they do? They started again analyzing it again and again and making getting into a new law. Okay. So who was the second scientist who came up with a new idea? It was none other than Newland. Okay. His name is Newland. Yeah, so what is it? It's Newland's Law of Octave. So what here it was triads, now it is octave. Have you heard octa? What does the meaning say? What is octa? It means 8, right? Yeah. So let's see how he ended up giving the law this name, law of octaves. So what is it? He again took these elements, what are Dobberiness took those elements and also other elements which were there and which was newly discovered at that time, and what he did do, he again started analyzing. As the again you see the time is, there were almost 50 years gap. After 50 years gap he came up with an idea. So there were 50 years, within that 50 years maybe the modern technology also, there was some new technology found it, so it was advanced and he had some other, maybe he had some other better technological instruments or something, and he started analyzing. He took a number of years to analyze and get into this law. Okay, so what did he do? He took all these elements, he started analyzing it again and again. He started analyzing more properties, right? What did Dobberiness do? He just mainly focused on atomic masses, the order of increasing order of atomic masses, and one of the property. But this person tried analyzing more properties, and what did he do? He built a extra, a bit more bigger table. What did he do? He classified these elements again. After I told you, after several analyzing process, he could see that in a set of 8 elements, that is in a group there are 8 elements. He classified like that. So each group had 8 elements which had similar properties maybe. So what did he see? He saw that the first element in that group had a similar property that of the 8th element of that group. Did you get me? So what is it? He saw that the first element and the 8th element of that particular group of elements had same properties. So what was it? The new Lands Law of Octave states that when the elements are arranged according to the increasing order of its atomic masses in a group of 8 elements, the first properties of first element is similar to that of the 8th element. Okay, so this is a statement. So you should always remember that you should write the statements, especially the laws, in the same sentence, like mentioned in your textbook is fine, right? Because definitions and laws have to be written in the same way, okay, with scientific words or the phrase, it should be the same. Okay, see to it. So what does the law state? The law of New Land, that is New Land's Law of Octave, states that when the elements are arranged in the increasing order of their atomic masses, in a set of 8 elements, the first element had similar property to that of the 8th element. Okay, yeah. So that's how, that was New Land's finding. Then did everyone like stop there? So did all accept this and are we following this? No, right? Again there was some small demerits in the same, in this law as well. So we'll see what was it. Okay, but still this person had came up with a next step, right? When Dobberiness was the stepping stone, he just went another level more. So we'll see what was his demerits now. When we come to the demerits of New Land, he actually couldn't group. He thought only his strong belief was that there were only 63 elements till then. That was the elements, a number of elements found till then. Okay, so he thought those were the only elements that are present in this earth, and no one can discover, or no other element are present and want to be discovered. So he was so stubborn, we can say, and he was like so self confident that no, only so many elements were there, and he then put that table. But after time passed on, he realized that there were new scientists who came up with a discovery of new elements, right? So, and when he took a chance to plot them again into this same classification on his table, he couldn't. He couldn't succeed in it. So after calcium, that is calcium, the atomic mass of calcium is 40, right? So after calcium, he couldn't classify or arrange the elements in the same order as he did for other elements. Why is it? After calcium, every eighth element had no similar properties. Okay, so what did he do? He just gave a chance, but it didn't succeed. Okay, so he tried bit changes. So he changed his table. He put two elements separately on top, which did not set into those groups. But again, that did not succeed, right? So his after again inventing, then I told you, right, as time passed on, there will be new discoveries and new scientists arising again and again. So again there were many elements, so he couldn't do the same thing again. No one did accept it. So what he did, his law, which was Newland's law of octaves, become a failure there. Okay, so let's move on to the next person. New scientist came up with new ideas. So what did he do? Automatically he should actually revise these scientists, like as a, you know, Vedas, how we refer to, and then he should make a modification, because this had some basic properties which did exist, which there was some truth in it, right? Yeah. So what did new discover or new scientist was, after, by that time, okay, by the new scientist came up with this idea, there were in discovery of noble gases also, and many other elements were discovered. So his Newland's law became irrelevant there. Okay, because noble gases are separately placed, and it cannot be, it doesn't have any particular or similarity to this classification. So what did the next person do, and who was the next person? Let's see who is it. He is none other than the Mendeleev. Okay, you would have heard, like, Mendeleev's law, Mendeleev's periodic table. There's a new word here, right? It was not just a law, it was a periodic table. He found a new table only for that. So what did Mendeleev do? How did he discover? What was his analyzing procedure? Let's see in detail about it. So what did Mendeleev do? As I told you, he had discovered a new table. What table? You would have known your dining table, or some tables, or writing table in your room, study table, right? You know also periods, that your class periods. Huh? There are many other periods. So it's not only that. So he discovered something different from all those. It's called periodic table. So periodic, what does periodic mean? I think you would have learnt in your physics basics, like periodic, that is a particular interval. So it may be time, one time period. In maths also you would have studied it. A certain time limit or a particular period, that's what is called, particular time phrase. That is called periodic. That means a repetition after a particular time. So, or particular number, that is it. So it's periodic table here. Let's see what it is in detail. What did Mendeleev do? Again, it's the same for all scientists. They took a brief idea about what the previous scientists have done so far, and then Mendeleev like analyzed that both of them had a similar property. That was what they had taken these elements and arranged it in a similar pattern, that is increasing order of their atomic masses. So did he also consider that main point, because it was common for both, right? So he considered that point and he kept it in mind. And then, keeping it in mind, he took all these elements, including noble gases and other elements. He actually took almost 63 cards. Okay, so I told you 63 elements were found. So 63 cards. He took 63 cards and he put on his table. He wrote all the names of these 63 elements on it. Then he started experimenting. What did he do? He was something different, and he was a bit more, we can tell that he was the main contributor for our modern periodic table, because he had his idea had very good hold. He was more clear and more intelligent and wise than the others. Maybe because of generation gaps or modern technologies again. Evolution goes on, right? Yeah. So what did he do? He started experimenting these elements, reacting these elements. How did he react? He took two reactive elements, which was common. What is it? One was hydrogen and other was the oxygen. He took these both elements and reacted with each and every elements to understand the rate of reactivity and what products would form and how was its hydrates form, oxides form. He tried all these experiments, several, with all these elements. And what did he do? Finally, he arrived at a particular idea. What was it? Some idea. What is it? He saw that like categorizing all these elements. What did he do? He took all the cards. I have told you, right? He arranged all the cards and he wrote every on each and every card. He wrote a separate name of all the elements, and then he took each element, wrote the property, like reacting. How was it reacting with hydrogen? How was it reacting with oxygen? What was the oxide formula, hydride formula? How many molecules did it react? What compound did it form? All these things. Okay, he noted it down. After arranging all, writing all this, taking every property into consideration, what did he do? He started placing that on his wall. He just stuck every card on his wall. Then he sat somewhere. He started day and night. He started looking at it. He started what may be the similarity, what was the demerit in them, why didn't they get the result, and he was staring at that. Staring at that board, what did he do? One particular day, he could realize that there was some similarity between some of the elements there. So what did he do? He moved those cards towards one side. And similarly, he could see that some other elements had a particular property, and then he grouped them to a side. So after grouping, rearranging and rearranging again and again, after number of segregations, replacements, rearrangements, he could finally end up in a particular form, that is periodic table. That is what, like he could put all these elements in a particular order in a small frame, that is in a table format. So we'll see in detail how and what is it. Okay, so he put up a table. So not like this. I'll draw it, but before that I'll tell you what he defined. He found two compounds or two divisions, basically. Two new words, not new words, but yeah, put it in a chemistry basis. What is it? He introduced the word period and groups for classification. What is it? He first found that these vertical columns, he named it as groups. Okay, and few horizontal rows as columns. Now, how do few people get confused to remember, like vertical are groups and horizontal are periods. Many have confused like that, get confused very easily. So how do you remember? For easiness, I'm just telling it like this. So you are writing groups, no? These vertical columns are group. You first write a G here. Okay, so these are groups basically. And what do you do? After G, what is it? H. So you are writing, just remember that you are writing ABCD in order, and after G it is H, right? So H is like this. So it's group, you are writing it here. So this is H, no? Similarly, to just remind it, it's just for, it's like a tip, okay, to remember, that's it. So always you don't put G here and P. Usually many students have done that. Therefore I'm telling you this. So it's groups, these are vertical columns. Now periods are horizontal rows. So these are periods. How these? So have you seen their particular number here? Is this enough? No. He had some particular number of boxes or grouping there. How many? Number of groups were 8. 1, 2, 3, 4, 5, 6, 7, 8. So he had 8 groups. That is vertical columns. And 3 periods? No, he had 6 periods. So let's make it 6. Yeah. Now what did he have? He had made 8 groups and 6 what? 6 periods. Okay, so 8 groups and 6 periods. Those are groups are in vertical and period are in horizontal. Yeah. Now what did he do? He arranged those elements. I told you, right? He had put all those elements in the board, like on the wall, and he had categorized it. Right? When he started arranging, one similar concept again derived from both. What is it? It's the atomic mass, the increasing order of the atomic mass. So he also did the same. He started arranging all that element according to the increasing order of atomic masses. And then what did he find? He found out that the elements that had in a particular group had similar properties, and in particular period, like across the period, they had some similar properties. Okay, so just not downwards or sidewise, it's both the ways. So these elements had a particular property and these elements had a particular similar property. Okay, that's how he ended up making this periodic table. So what did he do? He finalized this. He put all the elements here. But I told you, right, he was a bit wiser than the other two. What did he do? When he was analyzing, he could see some mismatches or some incomplete things there. What were these the main demerits of them? They had given no place they had no idea about future, like what if there were some elements that would have been discovered, like that would be discovered in future and had to put them or place them somewhere. They didn't think all about that. So what did he do? He thought about that. He knew that what if there are other elements yet to be discovered? How did he got into that conclusion, like the different from these two? How did he could see, I told you, right, he was staring at it, he was trying to analyze again and again. He could see that there were some missing elements. How could you say that? Like suppose let's say there was some element with atomic number, I am writing it here, atomic mass of 48. Okay, yeah, there was some element, let's say x, some element. Okay, yeah, so that particular element had 48. Now next element which he could find was, which had element with atomic mass 50. Okay, he had an element with mass 50. Okay, let me see, it's 50. Okay, I hope you can see, just understand, it's fine. And suppose it's Z. So he just thought, actually it was just his imagination, which may be or may not be correct, but he just allotted a space for them as well. What if it was there? So if some element yet to be found out, say Y was having 49 mass number yet to be discovered, so he just left that space empty. So he continued his flowchart or his table similarly. So he left spaces wherever he found that incomplete in between atoms or elements yet to be discovered. He just left that space. So he already allotted the space, and he knew that it has to be discovered someday, today or the next day, some years after, maybe after 200 years or thousands of years. But he knew this was something that had to be thought about. So what did he do? He finalized this table, and then he named these elements, right? There were no elements found, but then he just named it as Eka. He started, suppose this was aluminium, just think this was aluminium, he named this thing as Eka aluminium. Similarly, next atom, if this was some calcium, so Eka calcium, the next one, Eka. Okay, so he named on like that, but there was no element like that. But then just for his reference, he just did like that. Now he recorded all this, he plotted this periodic table, and he finalized like this. So what was his uh, than demerit, there was something which was very valuable in his periodic table. What is it? The main thing was the arrangement and the space that had been allotted there. Okay, these two points were very important in his table. And what does his law states? His law states that, so his law states that the properties of the elements are its periodic functions, okay, of what? Of atomic, of their atomic masses. So I'll tell it, repeat it again. The law of Mendeleev, or the periodic law, states that the properties of elements are the periodic functions of their atomic masses. Okay, so this is his law. So he finalized this, he concluded this, and it was a great achievement at that time. And even now, because we are actually using the same idea and the same table representation, but with the small modifications. Okay, so let's wind up the class here. As I told you, this is just a history of classification of elements, so the history did not stop, right? It continues again and again. So let's see further in the next class what happens. Did his periodic table got in like acceptance in the world, and was it carried on in further, or did some new person come again to rearrange them? So we'll see all this in the next class. Okay, so let's wind up the class. Yeah, children, so now before concluding, uh, let's just revise, right? It's better to revise then and there. So I'm not asking you to sit after this video, revise then and then, now start opening your textbook and study all this. That's not required at all. Now what you have to do is sit for 5 minutes closing your eyes. That doesn't mean this video is over, now you have to do. So it's not like that. Now only all who are watching this video right now should close your eyes. Okay, yeah, please do close your eyes. I'll tell you what I'm gonna do. I'll just start repeating all the important sentences right from the starting of the video, like right from the starting of this chapter. I'll be repeating each and every sentences so that you can imagine. Maybe you can imagine the way I was teaching, or what all I had written on the board. Like when I go on telling or repeating the sentences, try imagining in your minds. Okay, repeating these sentences also, which are important, like statements, laws and all, you should keep it in your mind. So let's start. Yeah, please close your eyes. Yeah, now let's start. What did we start with? We first started with the chapter name, that was periodic classification of elements. Okay, so what is it? Periodic classification of elements. I told you there are two important words. One was classification and the other was elements. Now, what are classification? They are categorization or grouping or segregation of any items, maybe compound, substance, any items, particles, matter, according or based on different bases, like shapes, maybe color, maybe quantity, maybe quality, size, age, anything. Okay, so what is classification? It's just basically grouping a similar set of matter or atom or substance, anything. Okay, yeah. Next was element. The definition of element, I told you it's important. What is it? The pure form of a substance with similar atoms or same type of atoms grouping together. That leads to an element. Okay, now after element, I just asked you how many elements were there, right? So till date, how many elements are known? There are 118 elements discovered, out of which 94 were naturally occurring. That means natural elements, which says they already exist in earth as such. Okay, yeah. And then later on we entered into the discovery of the way of classifications. What was it? Who was the first person to start with this classification? It was, who was it? It was Dobberiness, right? Yeah, Dobberiness. Dobberiness, what did he start? First, let me state the law. Now, the Dobberiness Law of Triads, right? His law was Law of Triads. So, what does triads mean? The set of three, right? So, it may be anything. So, what is it? Law of triad means when all the elements known till that date, actually few, not all did he take. He took few of the elements. He arranged them according to the increasing order of their atomic masses into a set of three, wherein he could find that the the atomic mass of the middle element in a triad was similar or equal to the average mass of the other two elements, one above and one below. So, what did he state? The Dobberiness Law of Triads states that in a triad, the atomic mass of the middle element is equal to the average mass of the other two elements. Okay? So, this is Dobberiness Law. And next, who was the person? He had some demerits because he couldn't arrange all the elements what were discovered in future. Now, next person came up with this idea. Who was it? It was none other than Newland. So, what was his law named? Newland's Law of Octaves, right? So, there it's octave, so it's 8. Then what did he state? His law stated like this. What was it? Newland's Law of Octaves states that when the elements are arranged in increasing order of their atomic masses in a set of 8, the first element had similar property to that of the 8th element. That was his law. Then came up a new person or new scientist called Mendeleev, right? What did he say? His law was a bit different, and it had a new name, 2 words included in that. What was it? It is none other than Mendeleev's law or Mendeleev's periodic law. So what does it state? Mendeleev's periodic law states that the properties of the elements are the periodic functions of their atomic masses. Okay, so these are the 3 important laws that we have studied, and the Mendeleev was the one who contributed the periodic table, and we concluded. So students, please open your eyes. Yeah, so this is a brief recalling, right? So you could recall all the things. So yeah, the class will conclude our class. I hope you have understood each and every law discovery and all the statements what I have stated. If not, let me know. You can text in your group, right? You can put your suggestions or any doubts, clarifications you have. You can just put it there and we'll be clarifying it. Okay, so yeah, let's conclude our class. Thank you. Stay safe.